Are we live? Nope. Good old YouTube. I'm guessing there's a delay on the stream. Just guessing. Let's wait for YouTube to confirm that we are live. There we go, we're live. Welcome, welcome, welcome to Amberskies. My name's Blades, Fraser Sharp, and I'm going to say hello to you all. Oh, that's obviously the wrong button. I'm always doing that. There we go. Hello to you all, it's 11:12 AM here in Britain. Oh, grief, it's early. So, Amberskies, www.amberskies.org.uk. And from here, you can get to the GitHub code. Look, GitHub code. And if you look under Amberskies QT, you can get to today's code very easily by just changing it from master to dev. There we go. And that's what we've got today. As you can tell, the actual dev part's been removed. And I've also changed World Builder into a console. What's that all about? Well, there's the hint. Window 3D is now fully inside Amber3D.sl. What's going on there, Blades? What's going on there? Well, you may ask. You very well may ask. This is what's going on. I've moved the window to Amber 3DSL. And now, if you have a look in Amber 3D, under OpenGL, we now have the window and the model warehouse. So, how do we tell the model warehouse what to load? Well, if you remember, we use a text file. Double files. So under the models, we have default, and we have default models.txt and default map.txt, which we will be working with in World Builder. What did we leave the stream with last time? Oh, we've got a new window now, haven't we? And look. Look, look, look. The window now works. Yes, I fixed the problem by putting a proper window in. We've still got the problem that it's too dark, obviously. And that's what I need to address straight away now. Because that's not gonna, well, rickroll it. So we can come out of view and we can press any key and that comes out of there. That's lovely. So we need to look at our shaders. And we are using this texture shader here, aren't we? With this fog. Make sure that all my fongs are still correct. No, they're not. So I can take line 42 off. Make sure that's correct. Yeah, that's correct. So that's better. Messing with shaders is never a good idea. Make sure I haven't messed it up in here. No, that's good news. So that's back to what it should be. And I want to leave those shaders just like that. We're on the texture shader at the moment, so let's make a new texture shader. So copy and paste. Why me? Why me? Why today? We'll have to do it in silly land. Okay, console resources. World Builder console. If you're wondering why I want World Builder to be a console application, it's because it makes it a lot smaller. We've dropped the size of this down to about 200k or something. That coffee's lovely. Oh, under GSL. I want to copy you. So copy, paste. That's it. That's what I wanted. So that's a copy of Vert. And I want a copy of the frag. Paste. I also want a copy of these two as well. May as well do it whilst I'm here. Paste. And paste. Right, so I've got all the files we're going to need for now. There we go. Let's see, what shall we call these things now? So these are World Builder textures. So build, yeah, we'll call them Builder instead of Thong. So let's start with you. Rename. So instead of calling them Thong textures, I'm just going to call it Builder. Builder.vert. Thong texture. Rename. Nothing really special going on here, is there? It's obvious what I'm doing. I'm going to write a new shader for our builder. No reason why we can't. Builder. And that's the whole point to this. Easy to change things. But do we have access to setting them? Probably not yet. But that'll have to change, won't it? So that's Builder. Lovely. Right, so we've got a new set of thingies. Including project. Thank you. Lovely. Oh, early day coffee, the best. What are we going to do with these new, yeah. Let's test it out on this one first. Let's get rid of the rest. What we want to do is ignore the fog. So there won't be any. So we can delete that. There we go. There's no fog now. I'm going to get rid of that. Build a texture frag. We need to get rid of the fog. And we do that quite easily. All we do is we take that bit up to there. Lighting times texture. We cut that out of there. And we paste it over that. Like that. And add a space to make it look nice. There we go. It's just lighting times texture now. Now we need to tell our program to use it. So where's our model builder? Let's have a look. Our resources done. I'll leave build a texture. The vert one. Yeah, I want that one. Yeah. Nice. That's a good start. Hey, we're doing well already. I wonder if anybody's tuning in. I have no ideas. Hello to you if you are. I'm going to go through the changes in Amber 3D SL in a minute. Anybody who's been following the series will notice we've got QGUI application now instead of Q application. We've thrown the widgets away. Widgets are 2D and we want 3D. So I've got rid of everything there is to do about widgets. And if you look in our console here, it now just says core and GUI. Yeah. No more widgets, no more 2D stuff. We're going to build our own GUI. And we're going to do it in 3D. Wow. Alright, let's see what our world builder's doing. So it takes in the window from Amber 3D. It sets up a timer. When we start the timer, it loops through and it will update Window 3D. So where do we want to set our shaders? We can set them anywhere. So I would think here would be better. Okay. So we're going to need a way of doing that. So we'll go to the window. And the window we're going to talk about now is here in OpenGL. So window is here. Model warehouse is the thing that creates the shaders. Okay. So that's what we need to change there. There's no good in me typing it in here because it just won't work. So where we've got that, we need to take in two shaders. So that's the first thing. When we start, actually no, do we have set shaders, do we? Already? Nope, we don't. I'm going to take the shaders in at the beginning then. We'll do it here. Alright, so you can tell also that We're inside Amber 3D, so I don't need to put it in anymore. So the code looks cleaner. This is still a mess, but hey ho, it can stay a mess for a bit. We will need a Q string. Yeah, simple as that. So Q string, and that will be color shader, comma, Q string, texture shader. So I'll add it to the constructor to make sure that it's done that way. There we go. That'll definitely make sure it has to be done that way. So we can add those now in here. So Q string, and that was color shader, comma, Q string, and that will be texture shader. That will be color shader, and that will be texture shader. There we go. And we need a comma. Done. So now we need to find out where did we make our world model warehouse, and we make that in here. So in here we need to know the shaders. So we delete it there. I bet we'll put it in initialized GL, haven't we? Yes, we have. We need defaults. We could use the Fong shaders as default. Yeah. Yes, we can. That's lovely then. So, Fong... What are the Fong shaders? Font color. And I'm going to use those as defaults. Font texture. And there's a reason for that. Because if we don't have defaults in, things could go very, very wrong. Very, very wrong indeed. Like wrong shaders everywhere. Plus, that is the default shader which I have structured Amber3D_SL to use. And that's very important as well. So now we need a way to set the shaders, or to replace our shaders. We store them, thankfully. Yes, we do. So we need to be able to set shaders. And what we will need for that is a void. Set shaders, open brackets, qstring, and that will be, whoops, still do that wrong for some reason. Qstring, ooh, color, shader, comma, q a string, texture, shader. There's a reason I am not going to just inline that. I want it as a proper thing. There we go. And this is why. So when we want to set our shaders, we need to create new ones, because we do automatically set them somewhere. Render all, projection, textures. Don't. We are setting our shaders prior. We are not setting our shaders at all. We have the ability to do so, but we haven't, which is fine. So how does it know which shaders we're using? Ah, batch render has done it that way. That's fine. So the first thing we have to do is that. We have to delete the ones that we have, and then we can do them again. So m_color shader equals a new that one. Color shader m_texture equals a new texture shader, and we'll just say it's texture shader. And then we need to set them. So it's the batch renderer, isn't it, that takes shaders? Batch renderer, set color shader, and that will just be m_color shader then. I'd already thought of this before. I'd already preempted it by putting that set color shader in. So I knew it was going to happen. At some point I would have to write this code. Batch renderer, set texture shader, to M underscore texture shader. And that's it. That sets your shaders. Okay. So now we can set new shaders. By the looks of it, I think we can. We're in Model Warehouse now, aren't we? Yes. So let's go to our window. Our window can take it as a separate operation, just pass it through. Or, yeah, we don't want to be reloading shaders every time. I'm missing something here. Does the world builder care about the shaders? No, not yet. That's right. We need it on the window when we start. Yes. Void. Set shader. Plural. And again, it's QString. Color shader. I'm just calling it color shader and texture shader. You can call these whatever you want. Texture shader. I just like it readable. There we go. There we go. There we are. Good, 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 good. There it is. So here, all we need to do is call the model warehouse and tell it what shaders we want. Okay, or do we? Model warehouse null pointer. Model warehouse is set up here. Yeah, I'm happy with that. We're just going to pass them through. And that's just going to be set shaders. And that takes a color shader and a texture shader. That's handy. Comma. Texture shader. There we go. And that's it. That's everything. So we can set the shaders to whatever we want now. Okay. So what we're going to do here is mwindow. Mwindow. Set shaders. And it's called builder. Ooh, don't do that. Builder color and builder texture. There we go. That's all we need. Just put that code into the library. Okay. Code's in the library. Build. See what happens here. Yay, successful. Do we still get our graphics? Nothing should have changed. Oh, yes it has. Oh, that's changed badly. So I missed a step here somewhere. What did that say? Oh, right. It's not linked. Unable to open file resources GLSL build a texture. Burton frag. Well, that tells us the error. Because I call them builder instead. Ah, right. Builder, 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 build. Mm-hmm. Let that update. One day, maybe. Thank you. But yeah, it helps if I read things. Alright. Yeah, we'll just rebuild you. Make sure everything's okay. Yeah. Unable to open file. Build a texture. Texture. .ver. Why? What? Alright, maybe, clean. I don't understand. B-U-I-L-D-E-R texture, yeah. B-U-I-L-D-E-R texture. Got it, found it. You, rename. Where that dot is, there's a space. That's better. Alrighty, we can go, we can go. That'll work. Honest. Oh good, it's checking through now, everything. Excellent. Full rebuild. And there it is. And you can see already that there's big differences now in the lighting. We can see. And there's big differences in the window. It works. Alrighty, we are getting somewhere already. We weren't supposed to get somewhere already, but hey ho, we have. Yep, that's right. Font texture dot vert. Yeah. Perfect. So what we've done is we've taken the fog off. That's all I've done. Make sure we take the fog off in colour, please. Oh, I've got a little surprise for you. So we'll just delete that. We'll delete fog. And we'll get rid of you. There we go. Alrighty. But you're now thinking to yourselves, what, but, oh, by the way, main changed. Yeah, we do our window first and then we pass our window in to the world builder. Because our window is in Amber 3D now. And you're thinking, but how do we know which model's going in? Well, it's actually quite simple. If you have a look in default under the models text, we have that. We've only got plain mesh. Interesting. I've got one here that might be interesting. Copy. Amber models, paste. Let's try that one. Why doesn't he put the lock on it? Oh well, doesn't matter. It's there. So if I was to... we have comments. Put in dice, for instance. Don't need anything else on that line. We need a space at the end. So if I change that and now run it, it should pick up on the fact that I want to load a dice. And it does. Where will it be? That's the problem. I just don't know where it's going to be on the screen. Oh dear. Because we're not doing 0, 0, are we? That can cause problems. We should really locate things at 0, 0, shouldn't we? We've got an offset going on. What offsets are we using? Oh no, we are using 0, 0, 0. Alright. Yeah, this is not how this is going to be designed, so I'll skip that one. I'll skip that example. Not sure I like it. Oh, wait a minute. No, don't like it. Right, that'll do. Yeah. The dice would have been... Ah, it's diagonal, right. Would have been there. So if I use diagonal, I might be able to see it, but I don't know how far away the light is, so stuff that. Okay. So we can put the floor in. That's great. But we've got no UI. So we can't click anywhere and just say, oh, I want to pick an object and plonk it there, for instance. Which is our next step. We need some kind of clicking mechanism. A clicker. How's about that? We need a clicker. The coffee's going cold now, so let me just think about this. We need to be able to click on things. Right, how is this going to work? Let's put the window up for starters. We'll think about it. Yeah. So we've got our terrain, which is a bit flat, but... Oh, Muppet. Oh, God. I think I need a tissue. Oh, God. Thank you, Muppet. He's got a cold. Haven't you, love? Oh. Bless him, bless him, bless him. I've got a tissue here. I'm just gonna wipe down the microphone. My apologies. Yes. Muppet was on my knee and has just sneezed. So the microphone has been cleaned off. And we shall get on with this and think. In the world of 3D, it's called a picker. So that's what we need to build. First of all, we need to start a GUI, a graphical user interface. But we want a 3D GUI. So let's put that in with all the rest of our 3D. Rename. So we're going to call it GUI 3D. Doesn't look right. Underscore 3D. There we go. I've just broken everything. I've broken the window. GUI underscore 3D. Save. Thank you. Who else did I just break? I broke an entity. Camera. Those are the only two things that use it so far. Underscore 3D. Okay. There we go, updated. Thank you. Now, in our GUI 3D, we are going to have a mouse picker. Which means, oh, I'll try and describe this to you first, won't I? But we'll put it in anyway. We'll add it. We'll pop in a header file. And we'll call it mouse picker. It's going to be done by the mouse, not a cursor or keyboard. Yep, I'll add that. New item. And that's called mouse picker. .cpp. Cool. I finished this yesterday, didn't I? Is it the 12th today? Yeah. That's what I was doing yesterday. If anybody's interested. I had a day off. What did I do? Moved code around. That's typical of me. Ain't that just typical? Hmm? Hash include mouse picker. And it's going to be in a namespace. So it's Amber 3D. Namespace. And that's going to be the folder GUI underscore 3D. Gosh, I like to make difficult ones for myself, don't I? Okay. Save. And paste. Lovely. I won't deal with OpenGL. We'll deal with mouse picking. Right, what is mouse picking? What you're going to have to imagine is that wherever we hover our mouse on the screen, there's going to be a laser going straight into the screen. And where that hits an object, that's the object we're going to pick. Because it's in 3D, we're going to fire a laser beam from our mouse pointer into the screen, and we're going to try and hit an object. In this case, hopefully the ground. We are then going to have to put a menu of objects up. And that's going to be interesting. So we'll try and do that as well later on. First of all, we'll develop the mouse picker. And then we will try and create a menu to pick from. So that we can just click on an item in the menu. It'll attach to the mouse pointer. We'll hover over the map and it will highlight wherever it's going to be placed. And when we click, it gets placed. If we right click on an object, we will be able to delete it if we wish to. That kind of thing. I think that kind of thing is probably very intuitive and more helpful. Okay. So let's have a class. Mouse picker. Public. Mouse picker. Will I be creating anything in here? No. Nope. It's going to be a utility class. So that'll do for now. I want it as an object only because it makes it easier to use. That's it. So, how do these work? They work by reversing what we did in here, in the renderer. You have to do the reverse of our render. Don't know if it's in here or not. No, it's not. So we'll look at draw texture, for instance, just as an example. What we do is we prepare the texture model. And when we prepare it, or prepare the instance, should I say, we work out the model matrix by multiplying inside the shader the M, the V, and the P perspective. So model view perspective. Now what we need to do is reverse that and fire a laser into the screen from our perspective through the view to the model to find out which model it hits. I hope that makes sense. So we are going to do that in stages because otherwise my brain can't cope with it. So I'm going to need some private functions in here that are going to do that stuff. And what are we going to have? Right, we're going to have vectors for starters. Because we're going to need 3 dimensions. So, hash include. Q a vector 3D. We are also going to be handling matrices, because that's what those things are. MVPs are all matrices. So this is what I know we're going to use. We are also going to need a way in which to get position of all models. Okay. I'll think about that one for a second. That'll be fun. We're going to call this test mouse. Okay. So it's going to read a mouse picker arrow test. And it's going to be a bool. No, it's not. No. We'll call it update. Hmm. Okay. What I'm going to do is I'm just going to do a void update stuff out. Because we want this all the time. We only want to know the result when we click the mouse. That's the way I'm going to use it. So we'll have an updater. Which means we will need to know what it's hitting, and we can test that at any time. Okay. And we can get a vector 3D back. I'm going to call it get current ray, because I'm calling it a laser. So we'll call it a ray, as in a light ray. Point? Don't know. That tells me we're going to need one. Yeah. We'll have one of those. Q vector 3D. M underscore current ray. That'll do. Which means I don't really need to do much here. I can just do return M underscore current ray. It will already be calculated for us. It'll be prepared for us. Yeah, I like that idea. We'll also need to know where on the terrain we are hitting. And that will be a 3D. So we can have that as well. Q vector 3D. Get current terrain point. That tells me we need a new variable. I'm good at this, aren't I? We're making this up as we go along. I've never written this before, so good luck to me. Oh, I have written it once before, only because somebody asked me to. I don't know what happened to that file, but they've got it, not me. Current terrain point. Current terrain. That makes sense. So here, all I need to do is put return M underscore current terrain point. So that's that one done. Do we need any others? Not really. No, don't like that. No, because we want objects as well. Model. It's not terrain, it's model. Let's be honest. Hmm. If we call it the right thing, it'll be easy for me to work out. Yeah, I'm happy now. So we only need that one thing, that's it. What else will we need? We'll need a range. Now I know the maximum distance we can see is 75 meters, and the maximum map size that we can work on at any one point is going to be 150 meters. Yes, 150 meters. So our camera is up in the air, and we'll be able to move around. Let's give the ray a length of... Oh... 400, no, I want double, don't we? 150 times 2. 300 meters. Const float. What we're calling it, array, aren't we? Ray range. Uh, 300. Yeah, I'll take that. Amount of checks we're going to do. Don't know. If it's 300, I think we'll only do 100 checks. So it's a recursion. I'll put that as a counter. Is 150. I'm going to do half. I'll just use it as a const, I don't care. Right. So we've got current ray. Current model point. We need models to check against. I'm thinking map. And I'm not using QMap, am I? If I remember rightly, and I've given up on QMap because I just couldn't be bothered working it out. I don't think there's any point to working it out, as it's going to do everything I need anyway. I don't need a specialised map. Let's see what else we're going to need. Camera might help. Where are we? Entities. Mm-hmm. And we have to reverse the process. So we're going to need the maths for that, aren't we? Hmm. Yeah. I think we're going to need those two. Not sure. I'll put them in anyway, for now. If I'm not sure of something, I'll just stick it in, I don't care. We'll take in the maths of the view matrix. We better take the other one as well then. Were those in line? Those are in line. Yeah, there's no CPP files. Okay. Create view, create model. They're in the wrong place. Don't put them here. They are not code for a header file. They are code for a CPP file. We'll pop them there. Anything that's in line and is just in the header file, I want in the CPP file. I want it to be compiled. I don't want it to be left out of the compilation. So that's good. Header files aren't compiled, by the way, if you wanted to know. I'll take the camera. Projection and models. Yeah. So that will be a Q matrix 4x4. I'll need the projection, which is worked out by Window 3D. And I need a models, or the models to check. We don't keep them there, do we? we do keep them here. I'll take those two. I thought we might use a map, but I don't think that's a good idea. I think that is a better idea. So we can include those as well. Starting to look a lot cleaner, this code. That's surprising me. I don't know if it surprises anybody else, but it surprises me the way I do things, because I just make it up as I go along, really. So we need color entity. Take you. Sorry, I'm typing with one hand at the moment. So speed is down because my other hand isn't working. God damn it. So that sorts that out. We've got a choice of where to put that. We can put that in the mouse picker, or to save us a lot of transferring backwards and forth. What a damn good idea. Because they could get large, those files, depending on how people want to use this. I mean, if they're using it for a game, it could get very large. So we can do that when we set it all up, I think. Here. I think that's a better idea. Ah. That's going to copy it. Pointer to a pointer. Yeah, so what? Pointer to a pointer it is. That's going to be awkward. That's going to be very awkward. Yeah, I'll take it. I don't mind. M_ color entities equals color entities, comma, texture entities is texture entities. This will have to have being able to change them, obviously, or update them. Yeah, it will. Yeah. In case we change our mind on which entities we have. So getters and setters. Yeah. Void set color entities. Is that one. I don't like getters and setters. For that. And that will just be m underscore color entities equals whatever you send in color entities. Semicolon. Alrighty. And void set texture. This is just the groundworks for a better system, I suppose. Woo, got that wrong. Entities. It's pretty obvious stuff. When you start thinking about how you want it to be used, I'm having to create the API at the same time as the function, unfortunately. And that is just m underscore texture entities equals texture entities, semicolon. Now, we've got all of that lot. I think that's all we're going to need. We can update from there. Magic, it's done it, right? Okay. Don't know what's in there. That's empty. That's good. Let's think about the kind of things we want to use, utilities, to help us do this. Think that might help. We are going to need... We're going to have to take the mouse and get its coordinates. So we need Q point. That's going to be the first stage. We need to know where the blammy mouse is. Oh, there's a blub blub. Hello, blub blub. Thank you, Discord. Hello. I'm not on Discord at the moment, but 1 second. Hello there. No, that's fine. Something weird coming through there. So I want Q point. No, I want Q point. So I want something to return that Q point. What is a vector to F? Q point gives an XY, doesn't it? Yes. So no, I can use Q point. So we'll have a Q point, and this will be get normalized. We want it as a vector. No, not a vector. A two-dimensional vector with a length of 1. And it's going to be the window. And that's coord. That's okay. Now that does mean I will need input. I'll need to know where that mouse pointer is. So I've got it there. It's in input.h, so we have the mouse pointer there. I think it's in a Q point. Tell me it is. Yes, it is. It's in a Q point. Right. I'm happy. What else will we need? We are going to need 4D vectors for the sake, because we're going to be using matrices, aren't we? Hash include matrix multiplication. Can I do it with a 3D? Good question. Don't know. Let's see if it allows us to. I mean, that's if you can ask questions like that in your own mind, look it up in the manual. So Q. Told you didn't know the answer. I know how to do it. I mean, that's obvious. We can map the vector. How are we going to be using that? We're going to be using the transform. Float. Oh, that's going to give us a Q transform back, not a vector. Oh dear. We can translate. We don't seem to have multiply. We probably... yes, of course we don't. We're going to need a Q vectors 3D map vector. No. Nope, I'm going to do it with normal calculation then. I don't think it exists. So yeah, hash include. Matrix multiplication requires a 4D vector. And as we already know, we just stick 1.0f on the end to get it to 4D, so the homogeneous coordinate. So that's simple. So as we are doing our calculations in 4D, our helper functions can be in 4D. Yes, we're not doing 3D anymore, we're doing 4D. We're going one step further. Great. So we'll have a Q vector 4D, and that will be produced by convert to iSpace. iSpace? iSpace? Is there such a thing? This is to do with the projection. Camera space. Because that's the first one we're going to have to do. We have to do this in reverse order. So we're going to use camera space first, and for that... Oh god, we need the coordinates, don't we? And this isn't making sense to my mind. I'm not sure. Simple. We'll work it out when we get there. Then we will need to convert to world space. And that will probably give us a 3D vector in an X, Y, and Z. I think it does anyway. Vector 3D. Convert to world space. It's not camera. Projection. That's view. Want it in reverse, don't I? I'm not sure what I want to put in here. I'm not sure what we'll have. We'll have that Q, well, we'll have the result of the first one, won't we? Vector 4D. We'll call it projection space. For now. No better way of putting that. So now we need the convert to model space. The M. That's why it didn't think right. Yeah. What will that give? I'll go with 3D again. For now. Until I know better. I know the first one is going to have to go to 4D anyway. To a model space. Once we've converted it to model space, we'll know which model it is. And that we'll have to take in a QVector 3D. And that's going to be view space. This is easy to make up, this. And at the end of all of that, we can calculate the ray. Yes, we can. And that will be an XYZ. Because we are now inside the model. Yeah. That's the bit that we're after. And that will be, what can we call it? How's about calc mouse ray, which is the ray coming from the mouse to the object, and it will be the object. It's where the ray hits the object is what we are calculating there. Okay. That's it. That's all we're going to need there. Trying to think of anything else we might need. Right, well, yeah, we'll have to cross the bridge of hitting the model after we've got the basics done. I think that's your basics. Then we're going to have to look at the models and see which one. Once we've got that ray, we've converted the ray, then we can check the models. Yeah, got it. So I'm just going to put that as a note. Right. For an intersection. And that's where we will use the recursion count because of how it works. And I'll have to explain that when we get there. If we get there. This is going to be hard enough, I think, for me today. My brain really doesn't want to handle this much. But hey ho. Hold on a minute. We should stop doing that. You have to train Microsoft, unfortunately, when you are programming, to do things correctly. It's not easy. Right, 4 thingies. which will give us our ray. I think I've got enough now to work with. Yeah, I think I've got enough. That alarm in the background is really annoying me. It's a house alarm. It does this quite a few days. And it's really annoying. Oh dear. So anybody got any hints on how to do this? It's the conversions that are going to be difficult, I think. Probably not. The conversions are just maths. Get normalized window coordinate. So we will need to know where the mouse is. So that will be Q point mouse location equals input not get mouse key press key release mouse position. There we go. That's easy enough. I'm just wondering whether I should assert that it's in the screen or not, but I don't really care if it is or not. If people want to fire rays off into Windows, I don't care. Windows can suffer. You can shoot Windows with an invisible laser gun that's now going to be attached to your mouse. That's a nice thought. That really is a nice thought. Yeah. So no, I'm not going to assert that it's in the window. I've got the mouse location though. What we're going to do with that? What? Oh, whoa. It's a key point, isn't it? And this is Windows. I wonder which coordinate system we're going to get. Interesting. I think it's the window. I think it is, but it might be the screen. But now that our window's working properly, because we're not using widgets, I think it's the window rather than the screen. I don't think we've got that problem anymore. And that's why the window's working properly. There's two coordinate systems going on. As soon as you open a window, there is the screen coordinates and the window coordinates. Because the window is placed on the screen. Let alone the 3 coordinate spaces that we've managed to create ourselves for OpenGL. Yeah, so we're in 5D now. Let's go beyond 4D. Nobody's ever done that. We're in 5D now. We've got 2 sets of coordinates. No, that's 6D. We've got 4D inside OpenGL, and we've got 2D on the screen. That's 6 dimensions. We're now in the 6th dimension. And we're doing maths like a boss. Do we need to reverse the Y? Don't know. Y is up in OpenGL. In which direction is it in Windows space? Don't know. Okay. I'm not looking it up. I'll know when it's wrong. May have poor reflect the Y direction from window to OpenGL. Depends if it's different or not. These are the problems you get when programming this kind of thing. We only need that bit, don't we? Really? Do that. Okay, that's that one done. That's an easy function. What we got here? That's not normalized. I'm just taking the mouse position, it's not normalized. How do we normalize it? We'd need to know the width of the display, the window. How do we get that? Isn't that in the projection? Oh no, it's because of the projection we need to normalize it. Dar. Okay. Yeah, that's easy enough. We can do that. Hash include Amber 3 E. And then we're going to go for OpenGL, and we are going to go for the window. And here we can go for our OpenGL. Window 3D. Star window. Yep, we can do that. No, we can't. It's because it's updatable. It's not static. So it'd have to come in the update. Yeah. Right, so we can add that to the update list. That means we need the window height and we're going to need 2 floats, aren't we? Yeah. Window width. Comma. Float. Window height. And I'm going to need you to. Lovely. It's starting to look better already. Right, what we have to do is make a new cue point. Let's just think about this. Oh, yes. We have to normalize it into OpenGL coordinates, which means the center of the screen is 0, -1 to +1. And the equation for that is mouse lock dot x equals 0.0f, we have to double it, times mouse lock dot x. We then have to divide that by display width, window width. Once that's done, we then need to remove 1 from it. So we've got -1 to +1. Yeah. Correct. And we'll have to do the same for .y. This is where we could put the minus in as well, if we need to. And we divide that by window height. And then we can -1 off it. Yep. Okay. That will convert it into OpenGL coordinates, and that's what we want to return. Return mouse lock. And that is now normalized from -1 to +1. That turns your mouse position into an OpenGL coordinate position. That is correct. Right. Next, we're done. Convert to projection space. The first thing we need to do is take the projection and invert it, because we're going backwards. Okay. Sounds good. Dot inverted. Right, okay. Let's do that then. So Q matrix 4x4. And this is going to be inverted. Yeah. Inverted, yeah. I haven't got it. How do you spell that? Inverted projection. Where is our projection? Our projection is here. We need it here. in projection space. There we go. It's starting to look a bit better already. Told you this was easy. Equals projection dot inverted. Qt is lovely, it'll do it for us. We don't have to worry about the calculation on that one. And then we need something else to create the vector 4D. Okay. I'm going to call it projection space. That's what it is. But what does it equal? It equals the transform of our inverted projection. What do we need for that? I think we are going to need our normalized mouse location. We need to transform it there. Interesting. Now I've got to start thinking about the update on how we're going to use it. How does a transform work? Returns the conventional 2D. No, I don't want a 2D. We're working in 3D. Work. No, I don't want to transform, I just want transform. Okay. That's a transform. Might have to do the whole thing. Do an anti-view matrix. Not sure how this is going to work. Any ideas, anyone? Any ideas? What do we need to do? What do we need to do? Convert to projection space. We need to transform by the inverted projection. Oh, I'm now live on my channel. Thank you for letting me know, YouTube. Bit late, aren't you? Duh. With reference to our mouse lock. That we've calculated. One times the other, isn't it? So projection space equals inverted projection times the mouse lock. Check that. We can check that because we already have it in our fongifongs. So we're doing this in backwards. So we want the inverted projection times whatever location we are. Then we want to get to the camera, that inverts the view. And then we want to get back to the world position, or the model position, which inverts the model times position. Yeah, that translation is there. So we just need that transform. Let's do that then. That means we are going to need a 4D vector. Come on, come on, come on. We can do this. We can do this. We're going to need the projection. and a Q vector, 4D, and this will be I think this is camera. Oh. What's the last thing we do? Camera. And it's delta camera. So where the camera is. That vec4 we need there. So it's that transformed by the position. So it's mouse position. Is it? Yeah, it is. The 4D mouse position. That's pointing into the screen at -1. Because we're at right angles to the screen. Our mouse is at yeah, mouse position, it is. Mouse picker. Here we go. 4D mouse pause. Yeah, I like that. I'm having that, comma. And now I know what it is, I'm happy. Copy, copy, copy. Convert to projection. That. And we just multiply them together, don't we? Yes, we do. Excellent. Oh, lovely, lovely doublies. So it's invert the projection. So it's inverted projection times the mouse position. Which equals... Gosh, I'm glad I got through that one. Inverted projection multiplied by the mouse lock. Mouse position, should I say. Pause. That's it. And that will give us a 4D vector which we can return, I think. Well, nearly, because we're going to have to make sure it keeps the -1 and 0f. Yeah. It's got to stay outside of homogeneous. It's not coming from within the world. The homogeneous coordinates will lock it into the world, so does it start in there or should we take it out? So we want to return a Q vector 4D from projection space. I want the x value. I'm going to drop this down. Right, so I want the x value. I want the y value. This is why it took me so long to think about this, sorry. I wanted to know what values I needed. -1 for z. That's the direction that we want it in. And the last one doesn't matter. It's not homogeneous. Really doesn't matter, because we're going to probably knock that off to make it 3D. To be honest with you. And that's got to have an F on it, otherwise it becomes a double. Is that correct? As far as I know, yes. I think it is. Any disagreements? Anybody think I'm completely messing up the maths on this? And yes, I do 4D maths in my head. Not 6D, but 4D. I'm not sure about that last coordinate. Should we leave it homogeneous or not? It's irrelevant. Last coordinate is not going to get used. Oh, we're interested in those three. We want the x, y, z. We're not interested in that. At all. So, I think we now have our convert to projection space. Okay. Let's try the next one. See if we get anywhere with that. Convert to view space. Okay, we have our projection space. We've just calculated it. It's 4D, and we want to slim it down a little bit, I think, at this point. So... Right, so we need a mouse ray. So we're going to need a Q vector 3D. And it's going to be a mouse ray. I've decided. Don't know what we're going to make it equal to yet, so that's that. And that's what we're returning. So we are going to make an inverted view. How do we make an inverted view? We need the view matrix. We need to invert it. Interesting. So we're going to take in projections. Let's start thinking our way through it. So to view space, we take in the projection space, which we've just calculated in 4D. That is correct. Right, so we do need... We've got inverted projection. How the hell are we going to do that? Q. Matrix. Let's do it. We'll find out how we do it as we do it. So we want an inverted view. There's view matrix. How do we create the view matrix? Is the question. And there's the answer. Camera. So shall we create the view matrix using the camera? I think we should. Where's the camera? Oh, it's there. It comes through in the update. So we're going to need the camera here. No harm in that. We'll have a camera. Give me a camera now. Okay. Q. Matrix. 4x4. View. Equals. Static view matrix 4x4. Let's just create view matrix. Camera. Okay, we can do that. So that is create view matrix. That doesn't seem to be happening. View. No, that's not working, is it? Amber 3D Maths. Okay. We protected it. Create a view matrix. And we only need the camera. Which is wrong. Why? Because that should have been a star. do it properly. We will copy that over to our view space converter. There we go, all done. Very nice, very tidy. And then this becomes academic because it's a view dot inverted. God, that makes it so much easier. Right. We've now got the inverted view, which is, this is exactly the same steps that we made in this one here. Exactly the same kind of steps, but it's the next ones along, that's all. What are we going to do with that then? Our mouse ray is going to equal something or other. We'll need a vector 4D. Because we need a multiplier. Vector 4D. And this is our view. Our ray passing through the view equals inverted view and we're just going to multiply that by a projection space. Projection space, and then our mouse ray equals q vector 3D open brackets ray view dot x just realised what I'm doing, I may as well do it the same as above. Do the same. Always do it the same. Standardise whatever you do. There's ray view, comma, well, obvious, ray view. And we know what the next value is. It's -1. There you go. Is that correct? No. It is not correct. It is array view. That it now takes on a value. And because of that, we will need to do something. We'll have to add ray view dot normalize to make it a value of 1 again, because by now all the calculations it'll have sent its skew width. Yeah, that's it. That's better. Yeah, now we can have a z value if it's normalized. Cool. So all I've done is sort of followed exactly the same calculations in both, which are the reverse calculations of whatever happens elsewhere. So that's the view matrix done. Now, well, once we've done that, it's in model space. Don't think we need that. One second. So we get the mouse. We put it into projection. We put it into view. I got this wrong. That's convert to view. That's convert to model. And that's not needed. Yeah, I agree, pudding. Meow. Bye to that one. Right, how do we calculate the mouse ray? We'll need the camera. That's for starters. Then we just call everything. We need to pass that through. Excellent. I'm hoping that Pudding isn't eating something back there. Is it just himself he's eating? Okay, that's fine. This returns a vector 3D. Okay, we'll have to make one then. So, how does this all work? How do we put it all together? Well, we start off by running them one by one. So, that's the first one. We will need the window as well. What's wrong with you? Window camera projection. Window camera projection. Okay. Declaration is incompatible with void. Blah 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 blah. Window camera projection. Put a star in. Well, the window will be a star as well, won't it? We're not taking the whole of the window in. Let's be honest. Let's get things right. There you go. You're okay now, mate. You can work. Yeah, we'll take you as well. Right, we'll have them too. Okay, you're happy. I'm happy. Oh, here we go. It's a fun time. We have some calculations to create. To calc a mouse ray. So the first thing we're going to do is get normalized coordinate. That gives a Q point. Window coord. And that will need window width. So that's window dot get, no, it's just width. Width and window height. There we go. Yeah, good point. That gives an int. That gives an int. Did I adjust for that? I didn't realise there were ints. Divided by. Doesn't matter. Next. Alright, so that's the first instruction we're going to need. We've now got our window chord. We now need to make a vector for D for the next part, don't we? For mouse pos. Okay. Q vector for D mouse pos. Call it, I don't care what I call it. Equals Q vector for D. This is obvious really because it's going to be Q point window coordinate. Why did I put a capital there? And that's going to be window coord dot x. I've just realised I put some dot x's and y's up here, didn't I? It doesn't come up now. Those are functions. Glad I checked. that's better. We have the wrong ones up here then. Yeah, that's right. Oops, the wrong way. It's now reading right, that's good. Yeah, that's okay. Alright, any others that I've missed? That will be set X. And that will be set Y. And that will be brackets. And that will be a brackets. I keep forgetting that Qt works slightly differently with its X's and its Y's. That's better. That'll work a lot better than it would do before. Normalize works. Yeah, no problems. Okay. We've just defeated some problems, that's good. Alright, let's get on with this now. We want 4 numbers. What 4 numbers shall we have? Let's have window coord. Because it's got 2. Only got the X and the Y, as you can see here. We need more. We need that -1. I'm going to actually put 1.0 here because I'm still not sure about this homogeneous thingy, but we'll have it just in case. Why not? I think we need it for that part. I don't think it really matters. Probably does. Oh well. So that's mouse pods. Oh, we can send that off now to the next stage, can't we? With projection. Do we have projection? We do. Yes, we'll add it then to the list of things we're going to do. You see now why I put those in there. There. And we'll add it in. We will add it in here. There we go. We now have projection. Our next command is simple. We've got projection, we've got the mouse position. So let's convert. QVector 4D. What should we call this one? View coord. Equals. Convert to view space. That one. And for this we just need projection. And mouse pause. Are we making it look easy yet? Right, so now we've got that. What do we need for the next part? We need that view chord. Is a projection space thingy. And a camera, which we've got. And that'll give us a Q vector 3D. And this is to get the model coord. So it's convert to model space. Now it makes more sense, doesn't it? Convert to model space. And for that we just need a view chord. What we just worked out. And camera. I think that's nearly about it. We just need to return something, don't we? I'm trying to work out why I've still got this here. I don't see it. Okay, what did I get wrong? Got a couple of red blotches here. What's that? Expected a bracket. Really? I see 3. I see 3. I've missed something somewhere. Nope. Nope. What's this here? What's going on here? Arf. Something wrong in there. We'll have to have a look at that. Right. I think we're done. Nearly. But we haven't sent a Q vector 3D back, which is our mouse ray. Ooh, that's gonna be fun. Let's see if I've got all of this right now, because that should be the final model coordinate. That should be it. Do I need to normalize this? I don't think so. I'm happy with that. I mean, the computer isn't for some reason, and I don't know why. Alright, let's just have a look at these again. It's telling me now that it's absolutely fine. There's no red marks whatsoever. I'll just clean it up, the code. That went well. Done it again, because I'm an idiot. People wonder why I do this. It's so everything's on the left-hand side, so I can put my notes on the right-hand side when I get there. Because I tend to note everything up, so that I don't forget. It's okay. That's okay. That's okay. Yep, that looks alright to me. Everything's on the left-hand side. Fantastic. And in here. That's okay. That's okay, not finished. Ah, right, I see. Oh, oops. Sorry. I forgot. You have to do it inside the brackets. There we go, that's you fixed. What I would do then is probably bring you out there to make it slightly clearer what I'm trying to do. Now you can see why I do this, because the number of bloody brackets can be annoying at times. Lovely. That reads a bit better. Okay. That reads okay. That's okay. 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 And that space is intentional. There's more to go. There's a lot more to go yet. That's the start of it. Yeah. So if this works, I'm a genius. If it doesn't work, then I'm a human being. How's about that? Alright, so the update. We just want to calculate the current ray, don't we? All we want to do is that. And that will then be able to be used. What should we call it? How's about current ray? Yep, I think so. Don't we have an M underscore? Yes, we do. Well, let's make it then. Current ray equals. And it's going to need the window. camera projection. How interesting. Just passing those straight through. Projection. Makes me wonder what other stuff we're going to need. And there you go. That's how you calculate your current ray going into the window. What good is that, you may ask? Well, we can use that. How can you put it? We can try and use that to calculate what it hits. We've now got the ray itself. We've now got a ray that points from our mouse continuously straight into the screen. And we will cut off our detection range at 300 meters. And we will try it at 150 different distances to see if we hit a model. Well, that's not quite true, but you get the idea. Does this work? Oh god, this is a bit I don't like. Doubt it. Stuff it will build out. Okay. No errors. I prefer it when there's errors. Because if there's an error, I know that it's working. I know that sounds stupid. When there's no errors, I don't know if it's working or not. Do we assume I'm a genius? Well, I don't. Far from it. I think it's spam time. No. And yes, I do fall back to C instead of using C++. Because it's nicer. It gives me a comma. What do I want for the first bit? I want m_current ray and dot x, and it's brackets. Here's a float, isn't it? X. Get it off. X. Constant expression float. Interesting. I think that'll build. Right, let's use it then. How are we going to use that? Well, we need to know the window, the camera, and the projection. There's only one place I can think of that wouldn't do that. There's only one place where the mouse is working. So the obvious place to use it is Window 3D. So hash include. It's the obvious place to use it, so that's what I'm going to try and do. Amber 3D. We're now in GUI 3D. Well, hey, we've actually got to the GUI. Finally! This is our first program in GUI. Well, no, it's not. It's our second. Input was the first, but I just dropped in an old one that I had. It's not even working properly if you look at the code. So, yeah, might do a new one. Actually, what I'll do is I'll change those around. Okay. There we go. We now have a mouse picker. I don't know if we can start it from here. We can't, can we? No, we can't. How do we set that up? Well, that's where we use it. So what do you need? You need this camera and projection. It's M projection, isn't it? Yeah, it'll be M projection. Yeah. Camera. We don't have. The camera is an entity. We don't know about any entities here. So we'll have to grab it from somewhere else. It doesn't go here. I'm putting it in the wrong place. My bad. It goes in here. Where all the stuff is, of course. So... this is the central nervous system of the whole thing, is model warehouse. Has to go after camera. That's that done. Alrighty. My apologies for that. It certainly doesn't go in there. There's no way it can, really, when you think about it. It can go in here, though. So, model warehouse. After the camera, we get m_mouse. Is it GUI? Yeah. And it needs stuff that we can't give it. Okay. So that's what it gets. Right. Who's got the stuff? Okay. Person who's got stuff is the renderer. That's where it's created. Easy. Easy peasy. I've got it now. It goes there. Right. So that's where we're going to put it. This needs to come from the batch renderer. Well, that's going to be a fun. So we want to get that map and that map. So, God, this is awkward. That. Copy. Paste. Star. Get. I'll call it color map. No. Entities. Sounds better. Return. And it has to be the address. I'm not copying that, the whole lot of that out across different object classifications. We can do the same for this one. Luckily. Star. Get. Texture. Entities. And just return. And you. Really, it should be and there. But I think that means something different. I prefer the and there. Never mind. Personal preference. Doesn't matter where you put it, really. Well, I think it does, but don't tell anybody. Alright, so we can now get those from the batch renderer. The batch renderer has been set up. At this point, I hope. This is going to cause a null pointer error. I can already see it happening. Reason being is that we may this starts off as a null pointer. But if we stick an update through before the first render, it's not going to have any models in it. The best way around that, to be quite honest with you, I know it's going to sound stupid, but it's true. Is to take those two lines out of there and rely on set color entities and set texture entities, which is better in this instance. So there we go. What was that, Pudding? You want some food? Does that mean I'm supposed to take a coffee break? Damn it, it's here. That's an awkward one. We're not using it yet. We're not actually looking at the entities, we're just creating the array. Good. We're not using it, so there you go. That means we will need to initialize it sometime. Or do we? Not really. It will look after itself, I believe. What time is it? It's only coming up to 2:30. Do you want some food? All right. What do we got here? Let's have a coffee. Coffee break. Go grab yourself a drink.
Feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights
Oh boy.
paint the skies.
We're back. Way. Bit of music. Why not? Fine then. We don't need it there. We can actually put it in here now. It doesn't need anything. Lovely. So how do we use it? Really easily. So I've got the camera here. We've got everything sorted out. This is where we are rendering. So during our rendering, yes, we are going to introduce the GUI. You might say, oh heck. But no, the GUI on this 3D is going to work at 60 frames per second. Most don't. Most go at 30 frames per second or 20 frames per second. I think Windows runs at about 25 frames per second. Pretty slow. That's Windows is always slow though. So m_mouse picker arrow set what we just added here, color entities, and all we need to do for that is m_batch renderer get color entities. What's wrong with our batch renderer? Oh my god. How many of those? Oh right, I've got you. Okay. So, batch renderer. We've got too many goddamn thingies here. That now doesn't look right. It isn't right. Oh, god damn it. I'll have to take these stars off. No, that's gonna copy it. That's interesting. So what's it actually trying to pass? Argument of blah blah blah. Incompatible with parameter type. That star. Interesting. I am going to have to take the star off. I'm not liking this. I am not liking this. But it is the name of that. Should be a star. Should be a pointer. Okay. So when it comes through to the mouse picker, yeah, this is the problem. Okay, we'll take those off. It's going to cause and be very, very awkward. And that might just mess it all up. We're not using them yet, are we? No, we're not. Gulp. You're happy? No, you're not happy. That's why. That's not a map. Okay. Let's do that slightly differently. It's easy enough for me to pass it through that way if... What I'm thinking of doing is making the model warehouse responsible for the map. Pulling it up one level from the batch renderer. And then just sending the two maps through. Which is easier. We're not using it yet, so... yeah. Yeah. Move the model maps to this file. Yes. But after we've done that, if we do it that way around, we can just do it in the update. If we have the maps in here, then we can do it in the update. Is there an update? Don't even know if there is one. No, render all is the update. Okay. So put all of the models in, obviously. So we would do another mouse picker here. And that would set texture thingies. And after doing that, we would be able to update. So m_mouse picker. And we know this works. This is the update. That goes like that. Semicolon. Whoopsie daisy. And what do we want? Window camera projection. What's window? We don't have window. We have MGL instead. So we're going to need that. Hold on a minute. Can't do it that way. Yes, we can. Of course we can. Goes there. Hash include. Amber 3D. And how this fits together now, so I'm happy. Discovered the way. There we go. And this goes after renderer. There. Well, it could go at the beginning actually. Window. It will go under OpenGL. Window 3D. Star. M_window. Semicolon. It's as simple as that. I mean, that's fine. Save. Lovely. Lovely, lovely, lovely. So go straight after the core MGL. And that will be open. MGL. Window 3D. And that's comma m_window. Window. Save. Comma. Open GL. Window. There we go, that's it. That's all it needs. The window is then set. That doesn't change. Silly me. Getting the pointers again. Right, that's correct. Window. M_window. Got a camera somewhere. Sure of that, yes we have. And projection. What do we call it? Come on. Alright, it's just projection, right. Fine. That'll work. Still need to put the model system into it, but the basics of it now should work. Ouch. No, we're not. It's that Q object. Okay. Fine. Yeah, clean solution. I'm not bothered about everything. Okay. No. Yes. Model warehouse, header 60s. I've missed something. No, I haven't. I know what it is. It's that. It's that macro. Make sure I haven't messed it up. I don't think I have. Which is fine. Comma, window, yeah. Didn't mess anything up there. And window, yeah. Nothing obvious. Anything in chat? No. Good. Nothing obvious. Coffee time. Because I do miss things. Like semicolons and brackets and God knows what. Just check what I've just typed in. Looks okay to me. This is Amberskies, isn't it? Oh, those areas are alright. But I can see them now. Mm-hmm. Yeah, we're missing something here. Bro. Bloody blum 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 blum. Have we got extras still in here? We have. Take that out. No longer exists. So, Amber 3D and you. Okay. No matching constructor for initialization of model warehouse. Really? QString, color shader, QString, text shader. GL window, correct. There isn't. You're right. Damn you. Where was it? Come back. Come back, error. Voice forgiven. We are in 3D window, aren't we? Nothing happened. I pressed the keyboard, nothing happened. Ah, that's fine. It doesn't like this. Okay. OpenGL functions, isn't it? I pass that through. Cannot refer to type member type. Yeah, okay. Hmm. That's an interesting one. I wasn't expecting that. Color shader, texture shader, OpenGL, and window. Hmm. That's an awkward one. Can't do it. Although that's what I'm sending through. That's what you get then. Simple. Void. Set. Window. Which will be an OpenGL window. Underscore window equals window. Expected parameter. Ah, yes. Right, that's you happy. That's you happy. And back over here. That's you happy. Yeah, you're all happy. And you don't have to do something stupid like that. So, we'll do it normally. There. M underscore model warehouse. Set the window to this. Absolutely allowable, but it just doesn't want to do this twice. I can understand that. Right, so we've got the window sorted out. Render all, yeah. What were the issues? 3. No rule to make target input.h. We've already done that. Model warehouse rubbish. I think that we have done that. I've just built the wrong thing, haven't I? Yes, I have. Ooh, nice. Mouse picker, header 31. Does not name a type. OpenGL window, start and window. That's coming from Model Warehouse header 52. It does. What's it talking about? Model Warehouse 52. That doesn't name a type. Alright then. That does. It does. Honestly, it does. Did I check that I put it into the profile? Where are we? OpenGL. Window 3D.h. Yep. It does. It names the type. Own up. That doesn't need that on it either. Interesting. Have I messed up somewhere? Probably. Did you mean GL_3D? Ooh. Interesting. Hold on a minute. I'm passing the window through, aren't I? Firstly, model warehouse is a queue object, yes. Window is a queue object, yes. Mouse picker isn't. It's got no access to objects. And I'm shoving a window in it, am I? Yes, I am. And the camera. Whoops. Yeah. That could cause problems. We'll just... That could cause lots of problems. Lots of white, then the red. I don't understand that bit. Right, let's start at the bottom then. Alright, these look like complete goof-ups. Set window int. Why is it doing such strange things? It does not name a type. Yes, it bloody well does. You pillocks. And then it's kicking out errors here because it can't find the type. Yeah, it tells me that that is a type. Has anybody spotted what I've done wrong? Because I bet it's a semicolon. Somewhere in my typing, I probably missed a semicolon. Amber 3D, OpenGL, Window 3D. So why does this not name a type? It's a class. It does not name a type. Yes, it does. Failing. Wait a minute. Wait a minute. Wait a minute. I've encountered something like this before. World Builder console. Build directory. It's in the make file. I think. Go away. You are confusing us. No end. Right. Now we can do a full clean. I've just cleaned out the wrong one, haven't I? Doesn't matter. go away. Okay. Clean. There's nothing there to clean. Yeah, that's it. Done. Come on. Go away. Okay. It has to rebuild the project now. And it's still rebuilding it like that. Where's the error? Where's the missing semicolon or something? It goes to mousepicker.h. Are we building in the wrong order? It's coming from window3d.h 310. Right, let's follow it. Let's follow it. Hash include a model warehouse. Next part of the problem is here. Which line is that on? The red mark here. There's no red mark here. I wonder if it's that underscore. Okay, changing all underscores. That's mouse picker done. Mouse picker is introduced in, not in here. So why have we got a red marker still? Oh, it's undone. Yeah. That's correct then. Yes. Okay. That should be alright now. I'm not sure why this window thing is all cocked up. Trying something out. Nope. Nope. Doesn't make a difference. Hold on a minute. Have I got extra lines in here that I can't see? I've got something in here that I can't see. The QObject macro does not have a semicolon at the end of it after Qt annotate class. Qt underscore object, comma, blah de blah. But it's a hash defined, so it shouldn't have. Okay. And that's what's upsetting it. Window 3D does not type. And what does it name? The problem is that and Window 3D are the same thing. Okay. That's a cracker. It's out of sync now. Yes, I know. I'm just getting to it, for God's sake. It's bloody faster than me, isn't it? Starts complaining about it before I even got there. I don't know. Oops. Correct. And everybody shuts up. What about in here? Okay, we've still got this mouse picker problem. Okay. Don't use it in here. Do use it in here. No errors. Come on, where is it? Must be errors. I'm sure I did a new one somewhere. Or did I do it in the title? I did it in the... Yeah, I did it in the constructor, didn't I? Right, okay. Alright. Let's try again. Alright, we're down to 5. 11. Still 11. Oh, God, it doesn't know. You're quite right. I have to change that. I have to change that. My bad. I have to change everything. This you don't really need to change, but I'm going to anyway. How do you rename the directory? Damn it. Change these, didn't I? Remove that directory, please. It's not empty, so it won't do it. Okay. And it doesn't exist on disk. Good point. I changed everything and didn't do it in the Dubry. So I've got to change it back. It can't do operations on things that doesn't exist. It won't remove it. Okay, don't care then. Stuff you. Input isn't affected, it's not in a namespace. Mouse picker is affected, that's all. Why have we got all of this? What is this crap? What is it talking about? Okay, I don't know what I did wrong. But there's something wrong on that line, and I don't know what it is. I'll stick it here. I don't care. So it is GUI 3D : a mouse picker, a star M_mouse picker. There's nothing wrong with that line. So does anybody know in the comments why is it doing this? There you go, let's be more specific, shall we? That's not been declared. Oh, right, you're getting that far down, are you? I haven't even done the first one. Wonder if it's stemming from somewhere else. Let's look down them all. We don't use that. Not used. Next. Yeah, you're telling me about something I've just removed. What? Right, okay. Had enough. Get out of my face. I'll do it manually. Just stop it. I can't even get angry at this thing. So, what do we got that I don't like? I don't like what you're trying to do with that build directory. So there's something wrong about that lot there, and I don't know what it is. Yes, I am sure. Also, in the world builder itself, build empty, good. You also have a debug directory and a release directory. Cut you out. X64, I didn't write it. Cut you out. Anything you want to be confused about, I'm about to cut out. That's looking okay. Empty. Didn't write you. Goodbye. You are the weakest link. Goodbye. Done. There we go. That's that done. Who can compile, do you think, today? Do you think it's going to be Visual Studio, or do you think it's going to be Qt Creator? Well, that's a good question. Because I really don't know what the hell it's doing. Okay. Mouse picker. Hello, mouse picker. You've got a queue object. Are you okay with your queue object? Probably not. Have you got any extras here? Let's just do that. Yeah, I thought so. Okay. Let's just do that. Nope, you're still jumping to the wrong place. No, you don't. Okay, so everything before that semicolon is wrong. Excellent. I should make you happy. We have changed it. Very simple. That's the only change I need to make. I believe. Oh look, no red marks. Interesting. So the code's correct. Missed one. I knew it was there somewhere, I just didn't know where it was. That's it. There's nothing wrong with the code. What about mock.exe? Pardon? I am not in charge of mock.exe. That's nothing to do with me. Not my error. .14.2. Hold on a minute. Has it been updated? No. What is it complaining about? MSVC 2017_64. You. What's wrong with your bin? Well, it's here. What's wrong with the application? What is wrong with the application? Yeah, you see it live. You see the problems of Windows. Why I don't like programming on Windows. Oh well, sit back and relax whilst he's checking for updates. Let's see if there's any updates. It'll get there in a minute. It's happy. I spend more time pigging around because of Windows than I do programming. And in the past, I've had to rewrite a program in exactly the same way as I wrote it before, and it worked after the rewrite. Yeah. Go figure. Nothing? Okay, nothing. Well, I'm bugged if I know. It's telling me that Windows 3D.h. Hold on a minute, we've got an inheritance and including error. '31 and 32. That's an include error. What it's trying to say is that at this time that we have included it, Windows 3D doesn't exist. That's what it's trying to tell us. We include Model Warehouse, but we haven't constructed. So we don't exist. Which includes Mouse Picker, which includes Windows 3D, where it came from. Got a loop. We have a loop existing. So when it gets to this line here, that doesn't exist. There is no window 3D at that point in time. The whole of the hash include. Oh. FFS. And that's the real problem. What a hash include does is put all of this, or whatever is in that hash include, just copy and pastes it. So when we come back to window 3DH, that there will copy the whole of this back into that there. So it'll come through all of this again the second time. and find that it's got no window 3D. It's still here. The second time round, they won't paste in. Hoping. Pragma once. No, they won't paste in. They'll only paste in once, but it causes a loop. Because that's got a Pragma once on it at that point. That's already pragmad. So it'll only paste, it won't paste that line in. And because it doesn't paste that line in, it doesn't exist. So that doesn't exist, is what it's really saying. That line is being deleted by the compiler. How do we get around that then? Interesting. One of the ways around it is to make Windows 3D a singleton. So that any program can just ask for the window. But this is a problem with C++, not with anything else. It's the architecture within C++ generates this kind of thing. What we can't do is that. Okay? So in that case, we can't do that. What we can do, though, is take in two floats. No, two ints. So what we would have to do is take in int. What did we call them? We're going to have to program it properly for once. Damn it. I know. Doesn't say things like that. So in here, we are using them for calc mouse ray. And in calc mouse ray, unused variable model code. What? Oh, we don't even return it. Oh. We went to all that trouble to calculate it, so I'll damn well return it. Yeah. Clever. Oh, you're so clever. So window doesn't exist now. What do you want it for? Width and height. And they were ints. There you go. There we go. Width and height, that's done that. We need to now alter that. To that. To that. Okay. Now our update to that. And that's just width. And IGHT. Okay. So we now have to change the update to include a width and a height. So model warehouse. I don't think we have to change anything actually. Much. Model warehouse. We already have that stuff there. I think we've still got the same problem here. I think we've still got the same problem here actually. Even though that is still correct. There you go. Can't initialize it. Why can't we initialize it? Because we are asking in the header here a window, and it's not here. But we would have the same problem. So where are we trying to initialize it? Here. Actually, I'll just take the whole of that thing out because I don't like it. Not being there anyway. What I'll have instead though is I will have a cue point. Caps lock was on. A cue point. Window. No, mouse lock. Instead. And here, no. Yeah, cue point. Window size. Size? Dimensions? Resolution? Size. Okay. And that's just going to be cue point window size. I didn't put an M on it. Now you know why I do. M underscore window size equals window. Something or other. Size. There we go. So I can do it that way. And that will be a lot better than what I was doing, which is passing a window around. I only need the window size. So just pass the window size around. A lot less memory. Right, so now we've got that in there. We can go for window size. No. No. We can go for M underscore window size. And that will be dot X, which is an int. M underscore window size. Dot Y. Did I spell that wrong? Yeah. Fantastic. All we now need to do is give model warehouse the window size, not the window. Do we know the window size at that point now? It's going to be a Q point. And the X is going to be this width, whatever it is at that point in time. And this height. And they are dubris. Are they? Ah, I see. Oh, it's a variable. Okay. Right, that's correct. Those are ints, are they? Yeah. Ah, so we're going to paint GL. That also, luckily, is done in resize GL as well. That gets called automatically. Is that line now needed? Because resize GL is called there at that bracket. That's not needed. We'll do it automatically now. Anytime the window resizes, it'll send it through automatically. To the model warehouse. Thank you. That works. Make sure that model warehouse hasn't got anything silly left in it. It hasn't. Okay. So we discovered what the problem was. Or part of the problem at least. In file included from model warehouse H330. Model warehouse does not name a type. Okay. Model warehouse should not have that in it. That is why. Let's try build again. We've already decided that that's a bad idea to do. Okay. Does not have any field named in window. That's correct, it doesn't. Well spotted. Because we've taken it out. Anything else you want to tell us about? And we've still got the mock not working. Because it doesn't inherit from QObject. And that was the real problem there. Excellent. I hadn't done that badly after all. Except making a bugger up of the architecture. Right, I've got to build. Finally. Okay, let's have a look at you. Can you build or not? Well, damn it, you can. There it goes. Who forgot his \n? Current mouse ray. We have a mouse ray. I didn't realise that printf needed a \n on it. Interesting. There you go. Escape character N means next line. Quickly build that up. We don't need the messages anymore. There we go. Where's our mouse? Ah, we're in the window now. That's happily moving around at X, Y. Oh, it seems to be hitting something there. They're all minuses though. That's a positive. Oh right, it's in do freeze, isn't it? Why have we got a 0.2 that's not really X, Y? I don't think the Y is working very well. Oh, it seems to be. Is this in speeds? It's only happening when I'm moving it. And the update is very, very iffy. Okay. It should also update when I do that. It won't, will it? That should be minus. That should be 1 minus 1. That should be somewhere else, and that should be somewhere. I don't know where this is. Oh, it's pointing to, isn't it? And we're at an angle. Got you. Giving me the camera facing direction. Yes. Okay. I know what it's doing now. And yes, I did add escape there. Escape exits a window, by the way. It's just something I slid in to make sure that I could just press escape. It was starting to bug me. So it looks to me as though we've got a ray. Catch a falling star. Not an array, but a ray. Interesting. That'll all work now. Will it work in Microsoft? Will Microsoft be able to pull its finger out and actually compile something at long last? It's a shame it takes me a different editor to sort everything out. Oh, I've got a warning. Oh, right, okay. Fair enough, I don't care. Don't care, that's a Microsoft thing. Yeah, this is working properly, actually. I think it is, anyway. Because I haven't got the camera in a standard position, I have no idea what the numbers should be. But they will be... Well, yeah, because up here is positive. Sorry, up there is positive. Over there is negative. Over here is positive on the X. So X positive is somewhere over there. Yeah, it is. Y positive. Oh my god, you can't see it, but it will be somewhere up here. So we're not going to get any positive Y's. It seems to get less of a negative. Yeah, it will be. It'll be less of a negative down here. Yeah, because we're closer to it. Right, fine. And the Z direction is facing slightly in. So it's not going to... Well, it's going to be 45 degrees. So it's only going to... Yeah, it's going to move between -5. Yeah, that's right. Because of the 45 degree angle. Right, that works, I think, ish. Good God, job done. All we have to do now is try and get the damn thing to hit something. Yeah, that's easy enough now. I think I've got the basic calculations nearly right. I'm not sure about my Y. Whether that should be positive there or not. Because -Y is below that. Down there. Right down there. Well, it's somewhere down there. It's only getting to -5.5. We'll see. We'll see. That might need to be upwards. I think it does need to be upwards, you know. No, because that's a ray direction. The ray is going downwards. Correct. Interesting. So I think we're close. And we have a clearer view of what we're doing. We haven't messed up our resources. Oh, I did put that dice in, didn't I? Let's have a look now. Default models.txt. Let's try it out. if he'll do it. No. For some reason it hasn't. Should be about there-ish somewhere, shouldn't it? So that was up and that way. He might just be out of view. There he is. He's here. We've got a dice, by the way. There he is. It's the only success I've seemed to have had on Blender so far is making this model. So yeah, you've got that as well. I mean, we could rotate it to make it look fun, but nah. I know it's there now. I can see it. I'm happy. So that means that the converter works. Fantastic. Although the converter is doing something strange in there, so I'm not going to build that until I need it. It does need a rework doing on its output now. Yeah, I am quite happy with that. So as you can see, we have no... In our world builder now, we don't have any OpenGL. We have a window and we update it. That's remarkable, isn't it? The only OpenGL that we have now is this. And that's what I was aiming to do. We have now detached the whole of OpenGL from our program. And we control it through a text file. That's what I was aiming for. I just wanted to show people how easy this is. All I have to do now is open a 3D window, pass it over to whatever I'm doing, like a game, for instance, not a world builder, but a game, possibly, or whatever. Using a text file, it will load in the models that I asked for. And as you can see, I'll show you it on disk. If we now have a look at our program, World Builder console, we've only written, didn't write that lot. So it's got main, and it's got World Builder console project file, and it's just got a CPP in a header. So all we've written here is... Where's the all gone? Oh, they're here. That and that. Yeah, that's all we've written, those 4 files. There's the world builder. It's takes in a window and it starts and it loops. That's it. That tells Amber3D_SL, our static library, to load that mesh, and it automatically detects the texture and loads the texture. Main just sets it up and starts an application to run the timer in the world. Who said that 3D was hard? That's what I want to know. Why is 3D programming so damned hard? We've now got a 3D program that is literally... yeah, this big. Constructor, empty. Destructor, we've only made a timer. Under start, we set the shaders, we build the timer, we connect the timer, and then we start the loop. The loop, we stop the timer, we update, we start the timer again. That's the whole program. And we are developing a UI. And it hasn't affected this program one little bit. Everything's gone into Amber 3D SL. That did today. And yet, our world builder is doing it. I don't know what that error was. As you can see in the background here, our world builder is doing something. No idea what it's doing, but it's doing something. We are going to find out. I'm going to attach my dice to those coordinates. How's about that? Wrong keyboard. That's why. There we go. And it's now 4:10. And we have the first stages of our graphical user interface. If we can get that dice to move around and follow my pointer, we are more than happy. More than happy. Because all I need to do then is make a model of an empty box, or just ask it to draw an empty box or an empty cube in lines, actually. We've got the box RGB. If I drew that as a line drawing instead of filled in with colours, or outfit it to be semi-see-through. Multiple ideas again. Which one's going to be best? Well, I think we're going to find out as we explore more into building worlds. Yes, folks, that was how it was done today. I'm actually quite happy with the results. I don't know if the results are correct, incorrect, or what. So don't start writing this code down and saying, yeah, Blades told me that this was right. No, Blades didn't tell you that this was right. Blades is just telling you that he thinks that he might be on the right track. So, first run with mouse picking. It's not hitting any objects. Well, we don't know if it is. But there we go. We'll commit that. Sync. Sync. Dooby-dooby-dum-dum. So, back over here on GitHub. Under our dev branch here. Under Amber 3D SL, we now should have Amber 3D, GUI 3D, mouse picker, with all of the architecture errors taken out. And that's how you develop new code. And the new code actually looks pretty clean for me for once. Normally it's just a splatter, but you can see, yeah, not finished. I think that's clean enough to test with and to play with. So yeah, that's not going to be hard to understand. That's good news. And on that note, I'm going to say toodaloos for today. Take care, stay safe, and play with the code all you want. It's there on GitHub. If you can't find it on GitHub, just go to www.amberskies.org.uk and hit that button. If you still can't find it, there's a contact me button just below. So, thanks for popping by today, and yeah, we are shaping the future of the web. And Mastering the Mix has just got in touch with me. Thank you to them. Take care, peeps, and honestly, stay safe out there. Where's that button? There it is.